Welcome students. In the previous class, we shall discuss about the evolution of stars. Today, in this session, I am going to explain the expression for radii of white dwarfs. When a star burns all its hydrogen fuel, it is made up mainly of plasma of helium nuclei and electrons. ಇಲ್ಲಿ ನಕ್ಷತ್ರ ಪೂರ್ತಿ ತನ್ನ ಕೋರಲ್ಲಿರ್ತಕ್ಕಂಥ ಹೈಡ್ರೋಜನ್ ಫ್ಯೂಯಲನ್ನು ಪೂರ್ತಿ ಬರ್ನ್ ಆದ ನಂತರ ಅಂದರೆ ಇಟ್ ಈಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಹೀಲಿಯಂ ಅಂದರೆ ಇಟ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಪ್ಲಾಸ್ಮಾ ಹೀಲಿಯಂ ನ್ಯೂಕ್ಲಿಯೈ. In addition to that, electrons. The gravitational force between the helium nuclei causes the star to collapse until the Pauli pressure of the electrons is given by the formula P equals 2 by 3 rho epsilon F. 2 by 3 times of rho epsilon F, where rho is the density of the gas inside the core, where epsilon F is the Fermi energy at absolute zero. Here the inward gravitation pressure is given by the formula Pg. It means G subscript indicates the gravitational, P indicates pressure. Gravitation pressure, inward pressure is given by Eg upon V, where Eg is the gravitational potential energy and V is the volume of the star. This is nearly equal to Gm square by R into 1 by R cube. Let it be equation 2, where M is the mass of the star. Here this is nearly equal to N mhe, where N is the number of helium atoms. Totally this indicates the mass of the star. The outward pressure is given by the formula Pp. Here subscript P indicates Pauli, P indicates pressure. Pauli pressure, that means outward pressure inside the core, is given by N by R cube into H slash upon Me into N upon R cube whole to the power 2 by 3. Here in this case, H slash is H upon 2 pi, where H is the Planck's constant. Here R is the radius of the star. On equating these two equations, 2 and 3, we get the final expression. The radius of the white dwarfs becomes H slash square upon G into Me into Mhe. Here Me means mass of electrons, Mhe means mass of helium nucleus. O to the power of 5 by 3 into M to the power 1 by 3. This is the formula for radius of white dwarfs. If we put the value, that means radius is nearly 700 kilometer, for M equals the solar mass. This means a white dwarf is a very compact object. Let us see the next expression about the radius of black hole. Radius of black hole. Here we consider the particle can just escape to infinity if its kinetic energy is equal to its potential energy. Then its total energy becomes kinetic energy in addition with potential energy. That means kinetic energy plus potential energy, that is equal to total energy. Here kinetic energy becomes half mve square, where ve indicates escape velocity of the photon. That means minus gm into capital M by R. It indicates minus of gm into M by R indicates potential energy of the photon. Since total energy must be conserved here, at the moment of launch we require Here of m square is equal to gm into m by r. On further calculation simplification, we get escape velocity is equal to square root of 2gm by r or 2gm by r whole to the power 1 by 2. Therefore, on further simplification of this formula, r is equal to radius of the black hole becomes 2gm by c square. This is the critical radius is called Schwarzschild radius. This is about the radius of black hole. Next expression is photon diffusion time. Here for this one, here refer the diagram here. Photons are produced in the core of the star due to thermonuclear reaction. Here photons move from the core towards outer surface of the star. ಇಲ್ಲಿ ಫೋಟಾನ್ಸ್ಗಳು ಥರ್ಮೋನ್ಯೂಕ್ಲಿಯರ್ ರಿಯಾಕ್ಷನ್ನಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಫೋಟಾನ್ಸ್ಗಳು ಪ್ರೊಡ್ಯೂಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಥರ್ಮೋನ್ಯೂಕ್ಲಿಯರ್ ರಿಯಾಕ್ಷನ್ಸಲ್ಲಿ ಫೋಟಾನ್ಸು ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅಂದರೆ ನ್ಯೂಕ್ಲಿಯರ್ ಫ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಆವಾಗ ಫೋಟಾನು ಕನ್ವರ್ಟ್ ಅದರಲ್ಲಿರ್ತಕ್ಕಂಥ ಎಲ್ಲ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ಸ್ಗಳು ಫ್ಯೂಸ್ ಆಗಿ ಫೋಟಾನ್ಸ್ಗಳು ಎಮಿಟ್ ಆಗ್ತಾ ಇರ್ತದೆ. ಇಲ್ಲಿ ಫೋಟಾನ್ಸ್ಗಳು ಈ ಕೋರಿಂದ ಔಟರ್ ಸರ್ಫೇಸಿಗೆ ಬರಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಇದು ಯಾವ ರೀತಿ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನು ನೋಡೋದಾದರೆ, ದ ಫೋಟಾನ್ಸ್ ಗೆಟ್ ಸ್ಕ್ಯಾಟರ್ಡ್ ಲಾರ್ಜ್ ನಂಬರ್ ಆಫ್ ಟೈಮ್ಸ್ ಬೈ ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬಿಫೋರ್ ರೀಚಿಂಗ್ ದ ಸರ್ಫೇಸ್. ಇಲ್ಲಿ ಫೋಟಾನ್ಸ್ಗಳು ಏನಾಗ್ತವೆ, ಡೈರೆಕ್ಟಾಗಿ ಅದು ಬರೋದಿಲ್ಲ, ಎಸ್ಕೇಪ್ ಆಗಿ ಬರೋದಿಲ್ಲ ಈ ಸರ್ಫೇಸಿಂದ. ಇವು ಈ ಸರ್ಫೇಸಿಗೆ ಬರೋಕ್ಕಿಂತ ಮುಂಚೆ ಇಲ್ಲಿ ಏನು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರ್ತವೆ ಕೋರಲ್ಲಿ, ವೈಟ್ ಡಾರ್ಕ್ಸ್ ಅಂದರೆ ಕಾಂಬಿನೇಷನ್ ಆಫ್ ಪ್ರೋಟಾನ್ಸ್ ಆ್ಯಂಡ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್. ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜೊತೆಗೆ ಆ ಫೋಟಾನ್ ಎನರ್ಜಿ ಸ್ಕ್ಯಾಟ್ರ್ ಆಗುತ್ತೆ. ಸ್ಕ್ಯಾಟ್ರ್ ಆಗಿ ಅದು ಅನೇಕ ಸರಿ ಸ್ಕ್ಯಾಟ್ರ್ ಆಗ್ತದೆ, ಫ್ರೀ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜೊತೆಗೆ ಸ್ಕ್ಯಾಟ್ರ್ ಆಗುತ್ತೆ. ಆನಂತರದ ಸರ್ಫೇಸಿಗೆ ಬರುತ್ತೆ. ಸರ್ಫೇಸಿಗೆ ಬರಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ, ದಿಸ್ ರಿಸಲ್ಟ್ಸ್ ಇನ್ ಅನ್ ಅಪರೆಂಟ್ ಡ್ಯಾನ್ಸ್ ಲೈಕ್ ಮೋಷನ್ ಆಫ್ ದಿ ಫೋಟಾನ್ಸ್ ಇನ್ಸೈಡ್ ದಿ ಸ್ಟಾರ್ ಲೈಕ್ ದ ಸನ್. ಈಗ ಸೂರ್ಯನು ಕೂಡ ಒಂದು ನಕ್ಷತ್ರ. ಇಲ್ಲಿ ಏನಾಗ್ತದೆ, ಸ್ಕ್ಯಾಟ್ರ್ ಆಗ್ತಾ ಅದು ರ್ಯಾಂಡಮ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಬರ್ತದೆ, ಡ್ಯಾನ್ಸ್ ಮಾಡ್ತಾ ಆಚೆ ಈಚೆ ಜಿಗ್-ಜಾಗ್ ಪೊಸಿಷನಲ್ಲಿ ಈ ಥರ. ದಿಸ್ ಡ್ಯಾನ್ಸ್ ಲೈಕ್ ಮೋಷನ್ ದ ಫೋಟಾನ್ಸ್ ಇಸ್ ಕಾಲ್ಡ್ ರ್ಯಾಂಡಮ್ ವಾಕ್. ಇದಕ್ಕೆ ನಾವು ರ್ಯಾಂಡಮ್ ವಾಕ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಚಿತ್ರದಲ್ಲಿ ತೋರಿಸಿದ ಹಾಗೆ ಅದು ರ್ಯಾಂಡಮ್ ವಾಕಲ್ಲಿ ಬರ್ತಾ ಇರುತ್ತೆ. The photons travels along a zigzag path from the core of the sun to the sun's surface. Finally, the photon escapes from the sun's surface. ಕೊನೆಗೇನಾಗುತ್ತೆ, ರ್ಯಾಂಡಮ್ ವಾಕ್ ಆದ ನಂತರ ಅದು ಸರ್ಫೇಸಿಂದ ಎಸ್ಕೇಪ್ ಆಗಿ ಆಚೆ ಬರ್ತಕ್ಕಂಥದ್ದು. ಡ್ಯೂರಿಂಗ್ their random walk, the photons which are X-rays photons at the core become optical photons by the time they reach the surface of the star by diffusion. ನೋಡಿ, ಶುರುವಿಗೆ ಏನಾಗ್ತದೆ ಅಂದರೆ ಎಕ್ಸ್ರೇಸ್ ಟೈಪ್ ಇರ್ತದೆ ಅದು ಫೋಟಾನು. ಅದೇನಾಗ್ತದೆ, ಆ ಸರ್ಫೇಸಿಗೆ ಬರೋ ಅಷ್ಟೊತ್ತಿಗೆ ಅದು ಡಿಫ್ಯೂಷನ್ ಆಗಿ ಕೊನೆಗೆ ಅದು ಫೋಟಾನ್ ಎನರ್ಜಿ ಕನ್ವರ್ಟ್ ಆಗಿ ಆ ಸರ್ಫೇಸಿಂದ ಎಸ್ಕೇಪ್ ಆಗಿ ಬರ್ತಕ್ಕಂಥದ್ದು. ದ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ರೇಡಿಯೇಟೆಡ್ ಔಟ್ ಪರ್ ಸೆಕೆಂಡ್ ಫ್ರಮ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ಎ ಸ್ಟಾರ್ ಈಸ್ ಇಟ್ಸ್ ಲ್ಯೂಮಿನಾಸಿಟಿ. ಇದಕ್ಕೆ ನಾವು ಲ್ಯೂಮಿನಾಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಅಂದರೆ ದ ಟೋಟಲ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ರೇಡಿಯೇಟೆಡ್ ಔಟ್ ಪರ್ ಸೆಕೆಂಡ್ ಫ್ರಮ್ ದಿ ಸರ್ಫೇಸ್ ಆಫ್ ದಿ ಸ್ಟಾರ್ ಈಸ್ ಇಟ್ಸ್ ಲ್ಯೂಮಿನಾಸಿಟಿ. ಅದಕ್ಕೆ ಲ್ಯೂಮಿನಾಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಇದನ್ನ ಆ್ಯಕ್ಚುಲಿ ಡೆಫಿನೇಷನ್ ಹೇಳೋದಾದರೆ ಡಿಫ್ಯೂಷನ್ಗೆ, ಫೋಟಾನ್ ಡಿಫ್ಯೂಷನ್ ಟೈಮ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಆ್ಯಸ್ ದ ರೇಷಿಯೋ ಆಫ್ ದ ಟೋಟಲ್ ರೇಡಿಯಂಟ್ ಎನರ್ಜಿ ಕಂಟೈನ್ಡ್ ಇನ್ ದ ವಾಲ್ಯೂಮ್ ಆಫ್ ದಿ ಸ್ಟಾರ್ ಟು ದಿ ಲ್ಯೂಮಿನಾಸಿಟಿ ಆಫ್ ದಿ ಸ್ಟಾರ್. That means photon diffusion time tau equals total energy upon luminosity. Here the total energy is E, luminosity is L. Let it be equation 1. Here we know that the luminosity of the star is given by the formula L equals 4 pi r square into sigma t to the power 4. Let it be equation 2. Here in this equation, r is the radius of the star and T is the surface temperature of the star and sigma is the Stephen's constant. Here the total energy is given by the formula. Here the integration from 0 to r, that is 4 sigma by c into Tc square into 1 minus r by capital R whole to the power 4 into 4 pi r square dr. With respect to dr, integrate this one, we get the final expression E energy is 1 by 105 into 16 pi sigma by c into r cube Tc raised to 4. That will be equation 3. Here in this formula, in the equation 3, the energy of photon, that is directly proportional to r cube, radius of the star, and directly proportional to temperature, absolute temperature of the star, that is 4th power of absolute temperature of the star, that is core temperature. Here substitute equation 2 and 3 in equation 1. On further simplification, we get tau equals, that means photon diffusion time tau equals 4r by 105 into speed of light c into Tc by t whole to the power 4. This is the photon diffusion time expression. Here, for example, the sun emits the energy in the form 1.4 into 10 raised to 39 joules. Then the core temperature is 15 into 10 raised to 6 degree Kelvin. Then photon diffusion time tau is equal to 1.2 into 10 raised to 5 years, or nearly 1,20,000 years. It means in free space, a photon could travel across the Milky Way in 1,20,000 years. This is about the photon diffusion time. Next, we understand the mass luminosity relation for a star. For this one, we know that from the equation 1, we know that photon diffusion time tau equals E by L. And modify this one, we get L equals E by tau. Let it be equation 1. Here we know that the energy of the photon from the star is directly proportional to r cube Tc raised to 4. Let it be equation 2, which is already derived in the above relation. That means photon diffusion time. It can be shown that here Tc proportional to m by r. Here the temperature of the core is proportional to solar mass upon radius of the star. Let it be equation 3. Here m is the mass of the star. Substitute equation 3 in equation 2. We get E proportional to r cube into m by r to the power of 4. That is proportional to, on simplify this one, r cube and r raised to 4 get cancelled, in remains r in the denominator. That means m raised to 4 by r, equation 4. Here the mean free path denoted by the symbol S. Here mean free path of the diffusion photon is defined as the distance traveled by the photon between its two successive scatterings. Therefore, the photon diffusion time is given by tau proportional to r cube by S. Let it be equation 5. The mean free path is inversely proportional to the mean photon intensity. That means S proportional to 1 by rho, that means density of the star, and also density means mass per unit volume, it becomes V by M. That means volume is 4 by 3 pi r cube here, and M solar mass. Here 4 by 3, that is, let it be constant, hence it is proportional to r cube by M. Therefore tau equals r square m by r cube into m by r. On further simplification and substitute this equation 6 and 4 in equation 1, we get L proportional to m to the power of 4 into r by r into r by m. Therefore, on further simplification, we get L proportional to m cube. Here m get cancelled, it remains m cube. R get cancelled, we get L proportional to m cube. The lifetime of a star is defined as the ratio between the mass and the luminosity of a star. Therefore, lifetime becomes m by L. That means it is proportional to m by m cube. On further simplification, here m and in the denominator m cube, one term cancelled, it becomes 1 by m square. Therefore, lifetime of a star is proportional to 1 upon m squared. That means inversely proportional to the square of its mass. This is about the luminosity mass relation. Next expression is internal temperature of a star. Let us see the internal temperature of a star. A star radiates energy just like a black body and loses energy obeying Stephen's Boltzmann law. To obey the law of conservation of energy, half of the loss in potential energy of the star is gained by the star itself in the form of kinetic energy, and the remaining half of the energy is lost by radiation. Therefore, the kinetic energy of the star becomes potential energy upon 2. That means half of the potential energy, let it be equation 1. According to kinetic theory of gases, the kinetic energy of the interior gas, that means ideal gas of a star, is given by, that is 3 by 2 into n k into T average. Here n is the number of gas particles and k is the Boltzmann constant. T average means average temperature of the entire stellar matter. Let m be the mass of each gas particle and the capital letter M is the mass of entire star. Then kinetic energy becomes 3 by 2 into m upon small m into k T average. Let it be equation 3. According to Viral theorem, the kinetic energy K is equal to the thermal energy of the star and is given by the formula K equals 3 by 8 into Gm square by R. Let it be equation 4. Here G is the gravitation constant, R is the radius. Comparing equation 3 and 4, we get the average temperature of the entire stellar mass becomes Gm into small m upon 4kr. If mu is the mean collision, so mean molecular weight, mu is the mean molecular weight in terms of atomic mass of hydrogen, then it becomes 1.67 in 10 raised to minus 27 kg. Then the final expression is the average temperature of stellar mass is G into m into, here m is replaced by small m is replaced by mu mh. Where mu is the mean molecular weight in terms of atomic mass of hydrogen. There divided by 4kr. Let it be equation 5 is the first equation of stellar structure, where mu is equal to 0.5 for all the hydrogen atoms in a star are considered to be completely ionized. In this way, the average temperature of any star of similar composition can be determined in terms of solar parameters using the relation average temperature of stellar mass becomes m upon mass of the sun, that means solar mass, where m is the mass of the star, into r sun upon r. R sun means radius of the sun upon radius of the star into the temperature of the sun, that means average temperature of the sun. This is equation 6. Let Tr be the internal temperature of the sun at a distance r from the center. Then Tc becomes core temperature. Tc indicates core temperature of the star. According to the linear star model, Tr equals Tc into 1 minus r by capital R, where small r is the, that is the distance from the center, that is the distance from the center, where r is the radius of the star. Here Tc equals T average at the center of the star and r is equal to capital R at the surface. This is about the temperature of the star. Okay, thank you.